Okay, class. Today we're going to talk about polynomials, and this will be our introductory lesson. So let's begin. Today we're going to learn to classify polynomials by degree and by number of terms. The vocabulary in this lesson is monomials, polynomial, binomial, trinomial, and degree of a polynomial. The simplest type of polynomial is called a monomial. A monomial is a number or product of numbers and variables with exponents that are whole numbers. So if you'll look down here in the list, we've got some monomials that are represented. We have 2n, we have x to the third power, we have 4ab to the a to the fourth, b to the third, and we have 7. Okay? Each one of those are just a number or a number and a letter, or a letter raised to a positive exponent, or a combination of numbers, letters, and exponents. Now, things that aren't monomials are things like p to the 2.4. If the exponent is not a whole number, then it's not going to be a monomial. If the exponent is a letter, that means it could be anything. It could be a positive number, it could be a negative number, it could be a decimal. So it can't be the case, okay? So it can't be a monomial. If you have a variable underneath a radical, it cannot be a monomial because any number could be inside that variable. So you could have a negative number, or you could have a decimal number, or you could have anything that would make it not a monomial. And you can't have a variable in the denominator because, again, that variable could have the value of 0. Which gives you a division by 0 error. Okay, so those are some reasons why something might not be called a monomial. Monomial, again, is a number or product of numbers and variables with exponents that are whole numbers. So let's see if we can classify a few. So right here, what I would like for you to do is tell me, is this a monomial expression or not? Okay, so A, would it be a monomial expression? Yes, because you'll notice that my exponents are whole numbers, and there is a whole number underneath the radical. So this is a monomial. So that one is yes. Okay, what about B here? Again, okay, we've got a whole number for a exponent. That's good. So we've got numbers, letters, exponents that are good, but we have a variable underneath a radical. So if we have a variable underneath the radical, that would be a no. Let's try again. Try these on your own. I'll give you a few moments. Okay, let's see how you did. For A, we have a whole number with a variable. That's good. We have variables that have positive exponents, have whole numbers as exponents, so this would be a yes. Okay. For B, we have a whole number, which is good. We have a variable with an exponent, but the exponent is a decimal, so that automatically makes it a no. Now, so let's talk about a polynomial. A polynomial is one monomial, okay, which is what we've just been talking about, or the sum or difference of monomials. Sum meaning plus, difference meaning minus, okay? Polynomials can be classified by the number of terms. A monomial has one term. A binomial has 2 terms, and a trinomial has 3 terms. So that should mean, should be easy to remember because mono refers to 1, okay, or mon. Bi refers to 2, and tri refers to 3. Okay, so let's see if we can classify these as a binomial, a monomial, or a trinomial, depending upon the number of terms. So in this one, it says classify each expression as a monomial, binomial, trinomial, or not one. So all those reasons why it might not be a monomial would also cause it not to be a polynomial. Okay, so now we know that what separates a monomial from a binomial is a plus or a minus sign. So if it doesn't have a plus or a minus sign, then it would just be a monomial for the most part. Okay, so A. Okay, we have no plus or minus. We have a single term, so this would be a monomial. Okay, so this one here, we've got a number with a variable with a positive exponent. And the second one looks like we've got two terms, but what kind of an exponent do we have here? We have a negative exponent, so this is not 1. Okay, not 1. Now C, we have a number with a variable, positive exponent, it's good. We've got another number with a variable with a positive exponent, that's good. And we have a whole number. So this is 3 terms, so this would be a trinomial. Okay, and for D, this one we've got 2 terms, so this would be a binomial. So let's see if you can try one on your own. I'll give you a few moments. Okay, let's see how you did. Okay, for A, we've got 2 terms separated by a plus. This one is a binomial. Okay, for B, it looks like we have 2 terms, but we have what kind of an exponent here? We've got a decimal as an exponent, so this is not 1. Okay, for C, we've got a number with a variable. Okay, so that is a monomial, so that one is good. Okay, and for D, we've got, looks like 2 terms. The exponents are fine, so this would be a binomial. Now let's talk about the degree of a polynomial, or in other words, the strength. Okay, the degree of a term is the sum. Okay, so we're adding the sum of the exponents of the variables in the term. The degree of the polynomial is the same as the term with the greatest degree. So no matter how many terms there are, okay, the term that has the highest degree value is the winner. That's the one that will be the degree of the whole polynomial. So you'll notice here we've got an exponent that has a 2 on it. So that means it's a degree of 2. This one's got a 5th degree, so it's a degree of 5. It's got an exponent of 5. Now this one's kind of interesting. We've got an x and a y, so how come it's a second degree? Well, if you remember correctly, the x has a 1 on it, and the y has a 1 on it for the exponents, because it's x to the first, y to the first. So the 1 and the 1 makes 2. And then here with this whole number here, we don't have an exponent, so it has a degree of 0. That's the only anomaly. So if we look at this polynomial, because anything after 3 terms, we just call it a polynomial, it would be the 5th degree because the largest one is 5. So let's see if you can figure some out. It says find the degree of each polynomial. Okay, so what you do is you take each term and you find its degree. Okay? And remember, the degree is determined by the sum of the exponents. Okay, so for A right here, we've got x. Well, that's x to the first, so this is to the 1st degree. If it's just a whole number with no variable, then it is to the 0th degree. So this one is to the 1st degree. Okay? For B down here, we've got 5 to the x. Well, that's x to the 1st. 2x to the 2nd, so that's to the 2nd. So this one's 1st, this one's 2nd. And the 6, because it has no exponent and no variable with an exponent, it is to the 0th. So what degree is this? To the 2nd degree. So let's try another one. Okay, so this one we've got y, which is to the 1st degree, 9.9, which is to the 0th degree. So this one is to the 1st degree. Okay. For B, you got x, which is to the 1st degree. We've got 4x to the 4th, which is to the 4th degree. And 2y, which is, again, to the 1st degree. So its total is 4th degree. Okay. So let's see if we can finish this up with just reviewing what we did over the lesson today. So number 1 and 2 says determine whether expression is a monomial. Okay, this one, we've got a whole number. We've got variables with positive exponents. So this is, yes, a monomial. Okay. Number 2, 3 square root of x. Well, the 3 is good, but we can't have a variable under the radical. So this is, no, it's not a monomial. Okay, classify as a monomial, binomial, trinomial, or polynomial. Okay. So number 3 here is, we got 2x squared minus 3x minus 6. That's a monomial. 3x is a monomial. 6 is a monomial, so this is a trinomial because it's got 3 terms. Okay. Number 4, we've got a term here. We've got a term here, so that means this is a binomial because it's got 2 terms. Now the last two, we're trying to find the degree of the polynomial. Okay, remember it's the sum of the variables, okay? So, or the exponents on the variable. So this one's got a 2, so this is to the second degree. A to the 5th is just the 5th degree, and 26 is to the 0th. So this one is total 5th degree because it's always the highest one. Okay, on this one we got 2c to the 3rd, so this one's to the 3rd degree. C to the 2nd is to the 2nd degree, so it's overall 3rd degree. So we've learned 3 things in this particular lesson. We've learned how to determine whether or not something is a monomial. We've learned what a monomial, binomial, and trinomial are and whether or not it's a polynomial or not. And we've learned how to determine the degree of the polynomial. Until next time.